Hello, testing the mic real quick. How is everyone? Andre is best student on the front row.
Oh, there is another one coming.
Okay, so sorry for the intermezzo. I was sick for 2 weeks, so this lesson is a little bit later than anticipated. Last time we went over how to make a menu in Unity, a little bit of basics on game objects and components. So this week we go a little bit more in depth and actually start prototyping our first game. I'm going to show what the end result should be after 2 hours. We'll see if we get there. It's quite a lot to go over. But basically, we'll make a little room where you can walk around with your character. You can interact with some chests and open them up. We'll have a door that you can open up and go out of and interact with. So basically, some fun little interactions with objects. We'll also add like a flashlight in case you want to make a horror game. These things are very standard stuff, and once you know how to do one thing, you typically can do pretty much anything you want. It's just iterative changes and making sure that you understand how the components work. Now, you could ask, why do we do this? As you can see, this is a very bare bones look. The character is literally a capsule. Typically in game design, we do a step called prototyping, where we will have an idea and we have to pitch it to investors or whatnot, or we need to make a very quick version of a game. So it's in a primitive state, it's playable, but it doesn't look good. And the main reason we do that is because, one, it's fast and it saves a lot of time. If we put a bunch of cubes in an environment and it's not what we want, we can just delete the cubes. Not a lot of time was wasted on that. But let's say a 3D artist needs to make a model and it turns out we didn't need it after all. That's a lot of time wasted. So that's why we do prototyping. You get to explore a lot of ideas and make a lot of versions very quick to showcase how the game would play out. And you'll see in these images, these are all from really popular games. The first one, for example, is Overwatch from Blizzard. As you can see, this is the level on how it originally looked. And now this is how it looks nowadays in the finished version. This is from Call of Duty, also Activision game. And I believe this one is from Uncharted. As you can see, there's very little detail in there. It's just bare bones to get the idea across. And that's what I'm going to be going over today on how to start on this. But the main reason we do this is because it gives you a sense of scale, of does my character fit in this doorway? You don't want to have a doorway that's 5 meters tall if your character's 2 meters. It makes no sense, right? So doing a block out and a prototype like this allows you to really understand what your level will be like when you're playing it. There's also a factor of wayfinding and lighting. Lighting, in general, you do later on in development when you have things already looking pretty good. But for some games, for example, like a horror game, lighting is very important, so you do that early on. So it all depends a little bit what the core concept of your game is. But in the end of the day, this is really a stage where you get to be creative and try different ideas and go very fast from one version to another without investing too much time in details. So let's go to Unity. I showed you last lesson, how to use the asset manager. I'll go over it again this week just to reiterate. But basically, Unity has an asset store. Unreal has it as well. These are pre-made elements, and we'll be using one today from Unity itself. It's called a first-person character controller. We could make this ourselves, but it's quite a lot of work. So using a standard asset is usually what you go to, and then you iterate on that and add more functionality as you need it. So usually you log in with your account from Unity. When you install Unity, you create one, and then you can literally just click the button, Add to My Assets. Then when you go to your project in Unity, you can go to Window, Package Manager, and then you'll have a button appear on top, Unity Registry, in Project, and My Assets. So since we need first-person controller, I'm going to go to My Assets, since I added it to my assets, and you'll see the starter asset shows up in here, and I can just import it or download it if I haven't downloaded it yet. But I have it already on my machine, so it knows it. That's the nice thing about Unity. It's pretty smart about that stuff. So I can just click import. And now it's going to take a moment. So as I mentioned before, this compiling of C# scripts, Unity is very smart in the way it works. Once you add a script with a class or anything anywhere in the project, you'll be able to reference to that class, and Unity will know where to find that file. A lot of other frameworks you need to like import and like actually specify the path, but Unity solves that for you. This is taking a moment. My laptop isn't the fastest, bear with it. I should have imported that in advance.
No, but it's fine. But it's you know, imagine you have a 2 gig or 4 gig assets. This sometimes takes an hour or so. You know. So.
Yeah. So here it gives me a little notification. This asset uses the new input system, and my project is using the old one. So it wants me to restart and enable the new one. We'll do that because we need the new one. So I'll just do yes.
What does an input system mean?
An input system is Unity's built-in, one second, let me save, is built-in like handling of like what keys are bound to what action.
Oh, okay.
So
The default key binding.
exactly. You can make your custom one as well, and there's a bunch of stuff built in for Unity. But most of these, like especially that's why I got this character controller from the Unity Asset Store. It handles the behavior, like the basics, like moving with WASD, spacebar to jump, that's built in, left click to fire or like whatever. Like these are built in.
If someone wants to make like a small game, would you recommend making something like this, or just taking it from the asset store?
Do you mean the input system entirely, or? If it's your first project, I would always use the asset store. Like this is provided by Unity for a reason. It's just very convenient. They have both the first person and the third person character controller set up. They handle the camera tracking of the character, like all the field of view settings. It's all built in, so it makes it a little bit easier for advanced, like actual big teams. They usually make their own because it's much more customizable, obviously. That's the thing. That's a choice that you make in the beginning. For our scope, since we're like beginning, we'll just use this asset because it makes sense. I also linked it in Skype, the link to it, so that should help. So
maybe just to add, you know, the old input system didn't support all the devices which are out here. Okay, so with the new input system, it's easy to connect to mobile. So touch things on the screen, so you don't have to do much. But then VR with those VR controllers, okay, so it's compatible with that.
Yeah.
So even if you're just making it on PC, you can then make it on mobile.
Yeah, Unity has build options. Let me show this real quick. So when you go to build settings, you can see here actually on the left side for what platforms you can build. So as you can see, it even has PS5, tvOS, I don't even know, that's probably Apple like TV. Obviously it depends what assets you use. Not everything is compatible with every platform, but usually like in the asset description it states it. But from what I'm going to be teaching, we're literally going to go, besides this asset, really bare bones, just understanding like how to do collisions, animations, interactions, a bit like that. So as you can see, we have a little folder here now called standard starter assets. If you have it imported, it should be in your assets folder, Julia. So it should be right here. Yeah. The confusion with Julia and Julia, it's So we have our first person controller folder, and in there we have a prefabs. Now prefabs are pre-made game objects. Usually they have components and stuff attached already as the creator of that prefab intended, which makes it really easy to copy paste it into your scene and really like make quick progress. So I'm going to remove the main camera here. I'm gonna add this main camera. I'm gonna add my player capsule, which will be my player character, and we're gonna add this player follow camera. So this may sound a little bit confusing, but the player follow camera will follow the player capsule. And then the main camera will display what the player follow camera shows. This is why we use this asset, because otherwise you have to program all this stuff. And as you can see, there's quite some stuff going on in here. So if I now move my player capsule, as you can see, it's not tied to it yet. So here we have to set up, let me have a look because it's been a while, which camera it needs to follow. So here we have our main camera, player input, oh, I think it's this one. So I need to think again, because this was prepared for like 2 weeks ago, but obviously with me being sick.
Is the player capsule the parent of something?
Yes, so it has some like the root, like where the camera binds to. That's why I said it's set up with like a bunch of pre-made things. That's why it's called a prefab. Let me cheat and double check because I forgot how to do this. So as you can see, we have our player camera, which is in the first person controller. So if we go to player capsule, we go down, we have our player camera. Main camera. Okay. I forgot how to do this. So machine camera. That's not good. Okay.
Didn't you set it up from the camera, not the player capsule?
I'm figuring it out because like I said, it's been a while since I've done this. Usually I follow the documentation of this asset itself, but I forgot to write that down. So player camera, yeah, this should be fine. So I don't know why it's not doing it. Okay, well, I'll figure it out. So basically, the camera will figure this stuff out. We'll start with the block out and how to approach it. So we're gonna add a floor first to our level. We're gonna make a 3D object and we're gonna call it use a plane. A plane is a flat surface, just really convenient, really flat. I'm gonna make it a lot bigger, and Z doesn't really matter. And I'm gonna give it material. This is one of the few things I've pre-made. I also put this folder in Skype. It has a material folder where there's a block out in it. The reason why I use this one is because it really allows us to understand dimensions a lot easy. As you can see, we have a big square, which is 1 by 1 meter, and a small square, which is 1/2 meter by 1/2 meter, which allows us to really understand how big things are, how much space it takes. So I'm gonna move my character up here. My character is 1 meter tall. So if I make it 2 meter tall, like you'll see, it's now a big character. The reason why I make it 2 meter tall is because usually a person is about 1.70 m, 1.80 m. So capsule is 2 meters, so it gives a little bit of an idea of how tall a person would be in this scene. So now let's start by adding some walls. So I'm just gonna add a 3D object. We're gonna go really basic here. Usually you can have a 3D artist who will make like a wall model or something, but like I said, we're going very bare bones. This is a prototype, so we're going to add a cube. I'm going to add this to 0, 0, 0, which is the origin of the world, and I'm going to put it up 1 meter so it's actually on top of the floor. I'm going to make it 10 long, so we have like quite a long wall, and I'm going to make it 2 high. So I'm going to put it 2 meter high. So I think the capsule itself is already 2 meter tall, so I can just set the scale back to normal and it should be fine. Yeah, this seems like the case. So this floor is floating, so let me just set this to 0, 0, 0 as well. And we don't need this cube anymore. So we're going to add the same material to this wall. As you can see, the material is not perfect. But yeah, this is our first wall. It's going to be our, I don't even know the direction. Let's call it the west wall. So now I'm just going to copy that wall a few times, and I'm going to move it around. So we have a second wall on the right, and then we're going to add another wall in the far side. So instead of X, we're going to change the dimension into Z, because we have a grid-based system. You have the X origin, you have the Z, and Unity uses Y in height. It's a little bit different than other software. Most of the software, or in Maat, you'll have Z as height, while in Unity you use Y. It's a little bit getting used to if you're used to other software, but it's not too bad. So I'm going to leave a little gap here, and I'm going to go back to my player capsule and my camera. I really need to figure this out, otherwise it's going to be really hard to actually set this up. So I'm just going to take these and copy them from this. The scene is also part of the asset folder. Okay, it doesn't want to do that, so that doesn't help.
Copy the components, right? You can just copy the components.
Yeah, I hope it works, but I don't know if it will. So I'm confused why it's not working straight away, but the problem I have right now is that I don't know which prefab is not set up properly. Oh, okay, I remember. So you gotta go to here, and then I think it is.
Look, there's follow here.
Yeah, exactly. And here I have to actually follow the route. There we go. Okay, so I forgot you have to tell the virtual camera, for the player follow camera, which route to follow. So in this case, you want the camera to be with the character because it's a first person one. So this is the player camera route. So if you want to select that, you have a little like circle thing here, which allows you to select which game object you want to attach to this. So here we'll use the player camera route. Now, if you press play here, not much you'll be able to do. You should be able to walk around. As you can see, I can walk around, and we have some walls. And the walls, since it's a 3D object, we use a cube, have a collider. Now, what is a collider? A collider is basically something that checks if your character, which has its own collider, somewhere, has a collider, probably here on the capsule. Yeah, no, here. The capsule collider. And if you press on this, you can see what the actual box is that you collide to. If you want to make this bigger, you can just expand it. And then basically anything that this collider touches, it will have interactions with. Now, you have multiple types of colliders. The main thing we're going to be looking at today is a solid collider and a trigger collider. So as you can see, this has a little checkbox, every collider, where it says is a trigger. And what that means is you can use a collider to trigger an event from happening, like you would have events in other programming languages. We can do the same in Unity. So what I'm going to do is I'm going to start on a little door. We're going to make something very basic, so I'm going to add a cube again. and I'm gonna set this to the origin. I'm gonna move this around, and I'm gonna move it over here. I'm also gonna move it upwards by 1, and I'm gonna make the scale vertically 2 meters, and I'm gonna make the scale in, X 2 meters as well. And I'm gonna make the depth quite a bit thinner. As we know, doors are, what is going on? I think my mouse freaked out for a second. Okay, we're good.
Is there a button to look at the object?
Yes, you can double click on an object and it's going to focus on it. I wanted to go above it so it can show, like, a door obviously is thinner than a wall, so we want to represent that, like I said earlier in a prototype. So now what we want to do is we want to add an interaction with this door. Now, usually if you think of a door has hinges, right? So you'll have a point where it rotates on, and that's never the middle of the door. So here we have a problem. As you can see, the center of the door is taken as our rotation, or like our positioning point, which is not helpful. So we can solve that. Usually your 3D artist will set it up for you so that this, what they call a gizmo, which is the origin point of an object, is on the bottom left of an object if it needs to rotate around a certain axis. So we kind of want this gizmo, as they call it, to be on the bottom left of the door, or at least on the left side of the door. So if we rotate, it will rotate on the hinge. So since we didn't have a 3D artist who was kind enough to make this for us, we can fake this. So what we're going to do is we're going to make a parent game object, and we're going to position this parent on exactly where we want this axis, or like this rotation point, to be. So now we have this over here, but you see that since it's a child, it moved with the parent, which allows us to do the opposite now with the child. We move the child over to the, we move it over 1 in the height and 1 to the right, or 1 to the right, sorry. And if we look now, this pivot point is on the left side of our door. So now we can rotate on this. So I'm going to rename this as door_pivot. And this we're going to call our door model. Doesn't really matter, and I typoed there, but whatever. So now we have our door. It doesn't do anything. You cannot interact with it yet. So what do we need? We need a few things. We need a new component for animations, right? So I'm going to add an animator. And as you can see, I don't have a controller yet. I don't have anything. But what we're going to do is we're going to go and we're going to create a new folder called animations. And again, these things are pre-made already in the folder that I sent on Skype. So if you want to check afterwards, or after lesson, or follow and you cannot follow, it's all there. So yeah. So what we'll need is we'll need a controller. So in animations, I'm going to create a new animator controller. And we're going to call this door controller. Now, if you double click on this, we have this, and this doesn't tell me anything, right? But this is our animator window. Here we can say what type of states a certain object needs to have. Let's say the door needs to be open, it needs to be closed, and it needs to have a standard position. So what I'm going to do is I'm going to create a new state, which is empty, and we're going to call this one idle. And now what we can do is we can open a window called animation, and I'm going to put this on the bottom. And what we'll do is we'll create a custom animation. Since it's a door, it's very simple, right? We rotate it 90 degrees for it to be open, or we set it to 0 if it's closed. So what I'm going to do now is I'm going to go back to my scene. I'm going to select my door, and as you can see, to begin animating door model, create an animation clip. I want to animate on the pivot point, not on the model, so I'm going to select door pivot. So what I'm going to do is I'm going to create one, I'm gonna go and set this up, and I'm gonna call this door. Oh, door open. I'm gonna save this. And now, I don't know if any one of you has worked with animation software or After Effects or Sony Vegas. Usually they use a system called keyframing to set up how long something takes. So as you can see, we have a timeline here. The timeline goes from 0 to like 55 seconds. We don't need quite as much. So what I'm gonna do is I'm gonna record, and I'm going to change. You can press shortcuts. If you want to rotate an element, you can press E on the keyboard when you select something, which allows you to rotate. And as you can see, as soon as I start rotating this, there's a keyframe now in the animation window. So I'm going to set this back to 0, and the door open, we start at 0. We start with the door closed, and then let's say after a second, so let's say after 60 frames, because 60 frames is usually a second, we'll do the door being open at 90 degrees. It might actually be per 60 seconds actually, and not frames. I don't know what this is set to, but we'll see afterwards. Again, I'm not perfect either. I'm learning as well. So yeah. So now we have door open, but we also want an animation called door closed. So what I'm going to do is I'm going to create a new clip. So where it says door open, you can create more animations for the same object, and I'm going to call this one door close. And then here I could do the same thing again, or I can go back to door open. I can select my keyframes and I can paste them here. And then I'm just going to select this and move them around like this.
Did you paste the keyframe at 0 or?
Yeah. So I'm going to swap them around. So I'm just going to drag them. It's a little bit hacky, but it works. And now we have our two animations. Now we have the animations, but we haven't set them up yet. But if you go back into our animator, you can see those two have shown up now. But as you can see, entry is the default state of an object when it gets loaded. And it's automatically changed it to door open. We don't want that. So I'm going to, again, create an empty state. I'm going to call this one idle. I don't know why I got rid of it, but it did. And I'm going to make transition to idle. There we go. Oh, I'm going to, no, it's right click on this one and set default, my bad. There you go. So now we have our idle position of the door. We have door open and door close. Good. Obviously, this door is not going to animate out of itself. So we actually have to handle that animation. So let me cheat again and have a little look, because I forgot. Okay, so we have our collider. Okay, so I forgot how I set this up originally, so I'm sorry. I will be better prepared next time. It was just, well, if there is a next time.
We'll just fire you.
That works as well. So.
Didn't you just add a script?
Yeah, that's the thing. I'm trying to remember where I add the script. So, because obviously the starter asset comes with some. Kind of forgot where I actually implemented this. So let me double check here, because I have my asset scripts, menu control, open door. Okay, so open door, where did I even add that one? So this should be just on here. Door prefab, it's not. Okay, so in my that's why I couldn't find it. In my previous test scene that is also in the folder I set on Skype, I had a little doorknob on it to look fancy. So I'll just do it on the door model itself this time. I can add a doorknob real quick, so I'll do that. So I'm just gonna add a sphere. I'm gonna call it door knob. And then we're gonna move this, I press W this time. W allows you to move, brings back the gizmo like we saw it before. And as you can see, this sphere is quite big. It's way too big. So I'm going to change it to like 1/10 of that size. And I'm going to put it over at the front. I also made the depth a little bit too small, so that's not good. So okay. Here we go. So our door has a little doorknob. So the reason why I use a doorknob is it makes sense. You want to interact if you get close to the doorknob. So here what we'll do is we're gonna change this collider and we'll make it quite a bit bigger. As you can see, this collider is the size of the doorknob itself now. So what I'm gonna do is I'm gonna make the radius like 10. So as you can see, anywhere now we get inside this collider, we will trigger the fact that we can interact with the door. And to remember that, since it's a trigger and not an actual collision box where you have to walk into something, we will enable the isTrigger checkbox. So now, what I'll do is I'll add a custom script. Now we'll create one and we'll call it door controller. As you can see, I don't have it yet, so I'm going to create it and add it. There we go. Okay, so now we can double click on the script here and it will open it in VS Code. And it's like the previous one we saw when we created the menu. We have quite a few things set up for us already. Now, as you can see, I have a chest open from before, and this will be my little cheat sheet if I forgot something. But as the previous time, we have a bunch of pre-made things we want to use. We want to use our pivot point where we'll rotate around. So we'll declare this and we'll call this a public game object called door pivot. Now, if I save this and we go back to Unity, you'll see that we can now define this door pivot in our inspector. So now I can just drag it in here and our script will know which pivot point we're talking about. So what else do we need? We have a pivot point, but we also have an animator. So we want to animate and use the animator to actually play our animations. So here I'm going to do the same thing. I'm going to call this a public animator door animator. Now, there's two things we can do. We can manually define or drag this animator in here, but we can also do it with code. I'm going to show you how to do it with code because it can be a little bit more convenient. So we know we have our pivot point and the animator is attached as a component to the pivot point. So it kind of doesn't make sense that we have to first tell Unity where is the pivot point and then also tell the animator because animator is part of pivot. So instead of doing that, I'm going to make this private and say you can figure it out yourself. So when this object gets loaded, the start function gets called. This is a standard mono behavior thing. I'd mentioned mono behaviors in the previous lessons, or previous lesson rather. This is a standard Unity setup on how, well, any script from Unity or any component uses. You have different types of behavior, but mono behavior will be used mostly. So what we can do is we can actually get this animator from door pivot. So what I'm going to do is I'm going to call door animator equals door pivot dot is get component animator, and this will get the animator component from our game object door pivot and store it in door animator. So if we save this now, we should not get any errors unless I don't know how to code.
So you're saving the whole animator in that component?
Yes. Well, I'm saving the animator component, or referencing rather, the animator component in this variable. And the reason why is because then I can actually address that animator with functions. So one of them, for example, is when we interact with the door, I'll be able to say door animator.play and tell it which one of the states I want to play. So we'll get there. So we have our little door animator. So now we need a few more things. So we have our pivot point, we have our animator, which we'll be able to use to play our own animations, but we have a few more states. We have to have something that defines if we are in the range of the door. So we can actually check if our player character is actually close enough. So that one I'm going to call private boolean, because it's either true or false. They're either in range or they're not. So private boolean in range. And then what I'm going to need as well is a current state. There's a few ways you can do that. You can store it in the animator, but I'm going to show you how to put it in a boolean because then it's also more understandable in code. So we'll need a private boolean is door open. You can call that different, but it makes sense to me. Now, this is our initial variables, but I want to do one more thing. Usually when you're in a game, you kind of want to know if you can interact with something, right? So usually what they do is they show a little interface icon that says press F to interact. We'll do something similar. You can do it in a UI element like the menu I showed last time, but you can also actually put it in the 3D environment. So I'm going to show you how to do it in the 3D environment. So let's say you want that button to show up at the doorknob, which we'll do now is I'm going to go to 3D object. I'm going to use text mesh pro. And I'm going to call this F button because I'm going to use the F button as well to interact with it. You can call this whatever you want. It doesn't have to be, but for me it's easy because then I know it's the interaction button. So I'm going to change this to F. I'm going to align this centrally, and I'm going to put this at 0, 0. And the reason why I want to disable this, how do I do this? There we go. So this gizmos is like the actual bounding boxes of objects. As you can see, this would be the bounding box of text. If it gets bigger than that, it would start putting it underneath each other. I don't need this right now, so I can just toggle it off so I can just see my F. Now I'm just going to rotate it 90 degrees so it aligns with the doorknob, and it's quite big, so I'm going to make it smaller. So I'm going to make this 18 font size. And I'm changing the color to black. So now we have a little F button. Well, we don't want this F to show up at all times. We only want to show it up if the player is actually in range. So what I'm going to do is we're going back to our door controller, and the script will mention this F button as well. So I'm going to say public because we want to find this and we want the editor to actually drag in that object. So I'm going to call this door interaction letter. This may not sound smart, but everyone has their own naming conventions. And now when I refresh, we have an error. Boolean could not be found. Okay, so we're missing a system thing, and I'm just going to drag these in too. Boolean is a standard Unity thing, so I think just having system will fix that. There we go. Okay, so that fixed it. So as other languages, you actually have to import the classes you're planning to use. Boolean is...
Would you need system collection and generic since you're part of the system already?
I'm not sure. I think you do, but I'm not sure on that, so I can't answer it. So yeah, now when we check, we have our interaction letter field here now. So I can just drag this in here and put it in our script so we know what we're referencing. Now, I'm going to disable this one, but it's manually disabling. I don't like that. So what I'm going to do is I'm going to disable that button the moment the object gets loaded. So now, like I said, the moment the object gets loaded in the scene, the start function gets called. So what we can do now is say this door interaction letter set active false. So now, let it compile real quick. This is the annoying problem. Like, since Unity indexes all the files, it recompiles before, as soon as you made changes to the code, but it makes it very fast when you actually want to test. So now if I press play, when I press play, you'll see on the left this F button is going to deactivate. There you go. So now if I look at the door, the F button is not there. Now what we want to do is, if we get in range, we want to show that F button interface. So how do we go about that? We'll need a few things. First, we'll, in the update function gets called every frame. So every frame it will check, is the character in range? That's what we want to achieve. So first, what we'll do is set up actually using that collision. For that, we have to set up a trigger event. So this will be a private function because we're not publicly going to use that. This is something that happens in the script itself. We don't call it from another script, so it doesn't have to be public. And since we also don't expect the variable to be returned, this is going to be a void. So this one will be called onTriggerEnter. And as you can see, I have a lint installed that actually helps with C# and Unity in specific. I can just press enter and it's going to fill it in. I don't know why it didn't double this up, but yeah. So onTriggerEnter works with a collider. And it will have the collider of the object itself and the other collider. The other collider is anything that interacts with the collider of this object. This can be the player character, this can be a projectile or anything else. So that's why having this collider referenced here is helpful, because then we can actually check what is colliding with our collider. So now what we'll do is we're going to check this other, and we'll check if the tag of that object is player. As you can see, I know this because this is starter asset. When you check here, player capsule has the tag player. So you know this is the player character that will interact with this collider. So now, if we collide with this, we know it's our player, so we can tell some more stuff. So the moment we enter this collider, we want to enable this door interaction letter. So we can do exactly the same as we did at the start. Door interaction. Yeah, I can just copy it. Set active true. So now, let's compile real quick. There we go. I'm gonna press play. Oh, it did. And I pressed play again because my laptop is slow, so it stopped. It's not helpful. Okay, so now, here we go. And when we get close enough, you can see the F comes up, but it doesn't disappear again when we walk away. So let's do that as well. So as we have onTriggerEnter, we also have onTriggerExit. And then we just set it to false. I'm sorry if I'm going repeating several things several times. No, because this is something that's built in Unity as well. This is part of the collider. So as you can see, when we get close, the F comes up. When you go away, the F disappears. Good.
So just because you check that is trigger checkbox, then you can use those two functions.
Yes.
And it will call them whenever it detects.
Yes. Plus, while that is trigger is enabled, it also doesn't act as an actual physical like wall or something. So collider can be a physical blockade. That's why sometimes in games you'll have invisible walls, what they say, like edge of the map stuff. That's also a collider, but not a trigger. That's a full-on collider. So making it a trigger allows you to like define an area where something has to happen. Let's say, and this is why I mean understanding this one allows you to do multiple things. Now I do this with a door, but you can do the same with a chest. You can do the same with a trap. Let's say you step on a trap and you want a trap to fall down, which you would do the same way. You would make a collision, you would call it a trigger, and then as the trigger gets triggered, you would tell a game object to start its animation or to activate it, something like that. But the entire process comes back for anything you basically do. So that's why I'm going over these, and let's finish this one up. So while we did the actual showing up of the F letter, we forgot to do something. We forgot to toggle our Boolean in range, that we are in range, because we'll use that. So here, I'm going to say in range equals true. And here I'll say in range equals false. So now why I want to do that is because now we'll use the update function. So far, I just did the interaction if I get close, but I'm still not able to open the door. So what I want to do is I want to open the door once I press a key. So how do we do that? Update gets called every frame. So to do that efficiently, I'm going to do an if statement in the start and say, if I'm in range, do the rest of the code, because otherwise you'll be calling a lot of code for no reason. So if the character is in range, we can use a key press. So what we'll do is check if a key is actually pressed this frame. So if keyboard dot current, and I'm going to use the F key. This resource, you can look up yourself, like what the key codes are. It's not like in JavaScript or something where it's a number. It's an actual reference to the name of the key. Oh, so in this case, it is key.f. And then what?
Can you make it dynamic?
Yeah, that's why you can use that input manager. But for now, I'm just going to show how to use one single key. Like
there is another way to make it so that it's X on the...
Yeah, exactly. So this is obviously hard-coded. Eventually you want to use an input manager if you do key binding customizable by the user. But this is a fast way to show it, and it's showing how to implement the entire input manager would be quite some work. So here I'm going to do a function on this. I'm going to check, was the key actually pressed this frame? Because think about it, if you press a key, usually you hold the button longer than one frame. So every single frame that key is pressed, it would toggle between open and closed, because it wouldn't know like exactly like when the pressing happened. So what I'm going to use is was pressed this frame. And this allows me to only do it during the frame the key was pressed the first time. So now we'll have to check. Is our door currently open or is it not? So we press the button, we know we want to interact with the door. So first thing I'll do is I'm going to check, is the door open? If is door open, it needs to close. I'm going to comment this out, close the door. And else, it needs to open the door. So I like to put some comments as well as I'm coding, so I know what the hell I'm doing. So
we need the default value is door open.
Yes,
Start.
exactly. So here we'll create a variable and we call it false. But it doesn't really matter too much in our case, considering this part of the code will never get called until you get in range. But yeah,
Now if you hold the button, wouldn't it open and close?
no, because it will only call this function, or this function will only be true if it was pressed during the frame it's in that update loop.
So it doesn't count it as if it was also, like if you're holding it?
No, like it will only call this function once. The moment, like if the frame was exactly the frame it was pressed. And that's why we use this. You could, if you wanted to, there's other functions as well. There's plenty of resources to find that. If you want to have something that is, if you hold it down, it does something repeatedly, you could do that. But in this case, we don't want that because we don't want the door to like flip around. So I'm gonna flip these around. So, because it makes a little bit more sense to open it before you close it. So here I check if the door is not open, I will open the door. So to do that, I'm going to use our animator. So what I'm going to do is I'm going to say door animator dot play. I think it's a capital. And now we have to say first what we want to play. So which animation, how long, and from what frame. So I'm going to say, let me double check what I called it. Oh, it's going to give an error obviously, but I called it door open. So I'm going to say play door open. And I'm going to do this. I need to double check what the other two variables are, but as far as I remember, it's like if you want to skip part of the animation and you want to say which keyframe you want to start the animation from, you can define it in here.
So you're saying it immediately from the beginning?
Yes. So this will play the door open animation, but then we also have to update if the state of the door. So is door open equals true. So now what we can do is we can copy this and we can place this here and then say door close and false. So now let's go to the console. So we're missing something. We forgot our input system. So keyboard.current is part of our input system. So we have to import that class as well. I hope that fixes it. And if not, I have no clue. Data annotations. Where is this coming from? Door controller 129. Interesting. 29 is here, but this is just like a, oh, let me double check. Yeah, no, I didn't have to declare it false, I think. So.
Maybe you have to declare it on the start?
Let me double check. Chest estimator is null. Oh, I probably have to say before I get it that it needs to be null. I'm not sure though. Component model. I have no clue where this error is coming from. Considering, oh, yeah, I don't need that. Why did that? Where did that come from? I think it just like when I pressed enter, it put something else there. Okay. Okay. Let's double check if I forgot something or not. But let's go into the game and see what happens. So now I go close to the door. I have my F thing coming up. And now when I press F, our door opens. But it's not happy. So it keeps playing. And the reason for that is because I didn't tell that the animation only has to play once. So let's fix that as well. So we have our animation, or sorry, we have our animator, which you can reach from here, or you can go to door pivot and then actually just double click on here. And now if you look here and we double click on door open, you see loop time is enabled. So a little bit confusing, and this is quite a lot of information at once. I'm sorry for that, but it's a lot of information I have to give at once too. So I'm going to disable these loop times. So now if I go back to my game, and to make it so I don't have to turn around every single time, I'm going to rotate my character towards the door. Right, here we go. Oh, here we go. That didn't help much, but yeah. So now if I press F, the door opens and it stays open. And if I go close enough to the doorknob, the F comes back and I can actually close it behind me. So that's basically how you set up some basic interactions, some animations. It's very rough, but it gets the idea across.
Let's just say that we want to move the player, like move his legs.
Right.
Loop time will be off as well?
That gets more complicated because that's like actual like blend trees and whatnot. So you can like, well, a blend tree is making one animation transition in another animation. So you'll have a standard pose, which will be an idle pose, where your character will be breathing, so they're moving a little bit, right? And then your running animation will be continuous until the state changes back to idle, where they'll use a transition. You can set that up. It's a little bit complicated, so I'm not going to go over that today. That would be more for like a specific like in-depth animation lesson, and we don't have the time for that right now.
You can also do that with the door, where you go from idle to open to idle to close.
Yes, you can do that indeed as well. So like I said, you can store the actual parameters in the animator as well. I just did it in code because it makes the code a little bit more understandable as well.
But my question is, do you need loop time when you do that?
Depends on the animation. Like if it's a cyclic, usually yes. Like for example, if it's a dance animation where it has to keep dancing forever, you'll have loop time enabled. There's a few more things where you can loop the pose specifically, but again, way too in-depth for this lesson. So as you can see, you have your transitions and whatnot, and like motion time. There's a lot of parameters and animations, and you can go really, really deep in this, but this is beyond the scope of what I'm trying to teach today. So I think we've been an hour, so probably take a break here.
Yeah, take a few minutes, 5
Yep.
minutes. Remember, switch off your sound.
Oh, sorry, Eileen. Yeah, okay. So I forgot again. I need to repeat the questions from the room. So yeah, to reiterate, Khalil asked a bunch of questions about animations and about like what if this requirement is needed for like a running animation, so the loop is enabled or not. I said it was a little bit too deep. I'm sorry, Eileen. All right. Well, we're gonna take a quick break, and we'll be back in like 5 minutes. All right, so we're back. Good. So there's a few more things I want to do. We went over the main things, so that's pretty good. But I want to go over some more things that iterate over the same concept. What I want to do next is I'm going to add a flashlight to the character. So if you would make a horror game, you can like dim the lights everywhere else and just use the flashlight. The reason why I would suggest a horror game is because horror games are really easy. Usually, like, there's very little detail in a horror game because since everything is so dark, it doesn't matter because you can't see it anyway. So a lot of like, when you look at like games like Amnesia or like really popular ones, as soon as you turn the brightness way up, you'll see all the flaws. There's quite a lot of them. But that allows us to like really like delve deep into actually making a game and making it simple for us. So, a flashlight, how does it work? Usually you aim at something and the flashlight, the beam goes there. So we don't want to add it to our character because the character is straight up and it turns left, right, and it doesn't actually rotate like this. That was our camera. So what we're gonna do, as I will show you in this one, we will actually add our flashlight. Yes, to the camera. So I want to check where I added it in this one. Here we go. So yeah. So I don't remember how I did the last time, but we'll just figure it out as we go because that's how we usually do it, right? So I'm going to, as we can see, this camera, I'm going to add a light. A light is just a game object with a light component, right? So I'm going to add a directional light. And the reason why I don't know if I should take a directional or a spotlight. Let me double check. Because this one is directional, but I don't think it's the correct one. So yeah, it's so in the player camera root, and we put a flashlight, which is a spotlight. Okay. Sometimes I have to think as well. So we add it to the camera root because that's what the system uses to actually follow the character and where it looks. And we'll add a light and we'll use a spotlight. So this is going to be called our flashlight. And as you can see, we can see the flashlight on the wall, but it's very, 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 very dim right now, right? So what I'm going to do is I'm actually going to increase the range, which will make our flashlight go a little bit further, and I'm going to increase the angle a little bit as well, but not too much. So we have the little fade on the edge, and when you use a flashlight, the edges are also less sharp than the the middle. So yeah. So now what we want to do is we want to actually be able to turn it off and on. So for that, we'll use our player controller. But this thing already has a first-person controller. So we might as well use the one that already exists. So I'm going to open this one up. And as you can see, this one is quite complicated. This is why I didn't do this manually in the lesson and why we got this asset. This asset has quite some stuff in here already. You could program this yourself. It's not that crazy. It just handles some movement in certain directions. It has some velocity, and it also has some clamping. If you're jumping on something, for example, and you're close enough to the edge, it's going to bring you over the edge. Quite some basic stuff, but it saved us a lot of time. So what we're going to do now is we're going to add our flashlight to this controller. So since we want to declare it again publicly in the inspector, we want to drag our flashlight in there. I'm just going to call this flashlight. And I'm going to call this one public game object flashlight. There we go. I'm going to save, and now we'll see in our first person controller a flashlight show up. Give it a moment to compile.
Remember to save.
Yeah, it's fine. So here on the bottom, it has flashlight. As you can see, it's now under cinema machine, so I don't like that. What I'm going to show you is how you categorize your stuff. You can categorize very easily by adding a header like this, and then you just give it a category name. So here I'll call it tools. There we go. Now when I recompile, you'll see we'll have a little subtitle called tools where a flashlight will be underneath it. If you want to add another tool, let's say a pickaxe or something, I don't know. There's a bunch of other stuff you can do. But here you see we have tools, we have flashlight. So now I drag my flashlight game object in there. Again, it doesn't do anything. But since we have an away going to start, I'm just going to set in start flashlight. Oh, did I call it flashlight?
Yeah.
Yeah, flashlight dot set active false. So now when we run the game, you'll see the flashlight turn off. It's the same principle as the letter F on the doorknob, but I wanted to go over it because that makes sense. Repetition is good to learn. So when we press play, give it a moment. My computer is not the best. You'll see both the F button and the flashlight are disabled. Good. So now, how do we check what button is pressed? Let's say we want to use the P button to turn on the flashlight. Well, I can go to the door controller and just literally just steal this code. And in the update, I'm going to make a function for this. I'm going to set I'm going to put this for here now. So I'm going to change this key P, and we're going to use flashlight state. So if flashlight, yeah. So we can do either variable Boolean, or we can just check if it's active as well. So let's have a look. So there we go. Flashlight. And now I need to double check because I don't remember this. If I go to here and I say check game object. Oh, my laptop is struggling. I need to Google some stuff as well sometimes. So, okay, I can just do if dot active. That's easy. If dot active, then we can. Well, basically, what we can do is toggle. So what we say is flashlight dot set active, and we'll use the current state and we'll do the opposite of that. There we go. And we do this in the object function because we check every frame. If that button is pressed, turn it on.
But you never made it inactive, right?
Well, you do. If you turn the flashlight off again, it needs to switch back off, right? So now, 1 second. Find the wrong one. Here we go. See if I didn't make any.
So now you disable it at start, and then when you press the button, it enables.
Yes, and if you press the button again, it will disable.
By itself? Like I don't remember you adding anything to it.
Well, that's the thing I did. So, so game object active is obsolete, so I need to change it to active self. So Unity changes. So I did.
Shouldn't it be a function?
This is a function.
No, and dot active. Flashlight dot active.
No, because it's a state. So this is already a Boolean on itself. As you know, a game object has a bunch of stuff standard. And this is that active self. So if this one is disabled, it will know it is disabled. So I'm in the wrong one. So let me save the code. And why I don't need a Boolean is because I use the state of the game object as the Boolean. I don't need a separate one in this case. The reason why I need it in the other location is because if a game object is inactive, scripts and stuff that are attached to that object are not going to run. So you cannot reference itself when it's not enabled. It doesn't work. So in this case, let's recompile. Oh, fun question. I keep forgetting to repeat the question. So the question was, what was the question again?
This one,
Yeah,
should it be a function?
yeah. So he wanted to know if Khalil wanted to know if this active self didn't need to be a function, but no, because active self is a parameter. It's the state of the game object. So I googled it because I didn't remember it at the time, which one it was. But this is basically this checkbox whether the game object is enabled or not. Sorry, Aline, I'm new to this still. So I'll use that as the excuse. So now when we load the game, you can see the flashlight is disabled. And now when I press P, it turns on. And if I press P again, it turns off. It's that simple. So it's a pretty, and that's what I mean with like understanding the fundamentals. This will keep returning for all kinds of stuff you do, whether you want to interact with a trap door, like if you step on it, you fall through it because it opens up or something. Anything you can imagine, and if you understand how game objects work and how to reference them, even like as you can see, I don't remember how to reference the state of the game object, whether it was enabled or not. It's as easy as Googling specific syntax as in any other language. But the same principles apply as a regular coding language to Unity. It's just a coding language. Every component is basically a script. Even this light component is a script. So understanding how to interact with these features and like the input manager and all this stuff will allow you to create anything you can think of. Obviously, for more advanced things, you'll start using mods, and then for some things you'll have to do research, but this is the basics that work for everything. Okay, so I'll show one more thing. I could show more, like I could show like the same principle as I did with the door. I can show you how to make a chest. If you want to see the chest, like I put it in the folder, it's basically exactly the same, so I'm not going to do it. It's too much work, but I'll show you how you make a prefab in case you made something that someone else can use them. So as you can see, I have my door here. Let's say I want to use this door elsewhere as well. So what I can do is I'm going to create an empty parent here, and I'm going to call this door underscore prefab. There we go. And what I'm going to do now is I'm going to add a folder, or there is already a folder with prefab. As you see, I have a door prefab and chest prefab. I'm going to get rid of the door prefab, and I'm just going to make a new one. So all you need to do is literally drag your game object down to the bottom, and it's going to create a prefab from it. And then when you want to, you can just drag this prefab in the scene, and as you can see, the door arrived already on the scene with the little F button. And now if I rotate it and put it like this, and put it like here, you can snap to the grid as well. I'll show you that as well. So basically, you have pivot, global, and you have here toggle grid snapping. So now if you toggle that on, it's only going to move per half meter. This can be very convenient if you want to like make something that's very accurate. But yeah, so now that door is there, let's see if it works. I'll just run the game, press play, and see if both the doors work. Obviously, you could think like, aren't they gonna collide since they have the same variables? Not the case, because every component has its own stuff. So now, as you can see, both doors work. And this makes it very convenient. If one person makes a chest, we can use that prefab in any level of your game, and it's going to work because you predefine everything and it saves a lot of time. And that's why, like, usually you'll have one person making the game objects, the animator will supply the animations, and the models will be supplied by a 3D artist, and then whoever is the level designer will just use these prefabs to build everything. So now we have our little prototype, and this is a prefab prototype, but once the actual artist came in and made the full door, like a wooden door, like let's say in Skyrim or something, is going to be every single time the same door. One person once made that and they just put it everywhere, and then every house is going to work. And that's the beauty of like the system of Unity. It's very convenient to reuse pre-made stuff with the prefab system. So yeah, that's pretty much it. I don't know if I have anything else I should go over. Are there any other questions?
Well, you can repeat the question after I ask it.
I will.
So let's make one door red and one green. How would you do that?
Okay. So the question was,
From prefabs.
okay, so the question was, let's change one door red and the other one green. You like making it hard for me, right? So let me stop the play. So obviously this is now a prefab, which is annoying. So how would you change one material, like one door red and one green? So what I would do is add a different material to the door. So what I'm going to do is I'm going to create a new material. Create material. I'm going to say red material. There we go. And I'm just going to change this to red. There we go. As you can see, this material is a little bit shiny because it has a smoothness factor. If I turn this down, it's going to be matte red. So I'm going to do that. So I'm going to make a second material. I'm going to make this one green material. And I'm going to make it blue just to be annoying. So now we have a green material that's blue because I'm colorblind or something. So now you can literally just drag the material on the door. And there you go. That's it. That's the response to your question. So now if we're in the game, we have a beautiful red door and we have a blue door.
Do you need to make a new material, or can you just?
You can change it with code and stuff as well, but I mean, for this sake, I just did a different material. Yeah, so you can also, again, since this is all handled by code, you can target the vertex color, or like in this case, the albedo, and actually change what the RGB value is. So you can do that, yes. The question was, I forgot to repeat, do you have to make a new material? And the answer was no, you can also do it through code, but making a material is more convenient.
For reuse, right?
Huh?
For reuse.
For reuse was the question, and I said yes. Plus, I can use the same material anything I want. If I want to make my guy green, or blue rather, because I'm weird, I can make him blue, because now I'm a Smurf. Yeah, so having materials is pretty convenient. There's a few other things like shaders, like for example, water in games usually are done with a shader because it moves, so like it has a lot of math tied to it. Those are a little bit more complex, I'm not going to go into that. But materials is just like a texture or something like you want to put on an object. Materials also use shaders to actually render them, so it gets really confusing. That's why I gave this material for this wall. This uses a custom shader I made to actually have that always be the exact same distance and whatnot.
Can we change all of the materials from like the prefab, or do we have to change one by one?
You can.
For example, now you have the door and the prefab
Yeah.
is blue, right?
Okay, so what I can do is I can, if you want to, the question was, can we change the material from the prefab, or do we have to go everywhere and change it? So the nice thing about a prefab is if you double click on the prefab, you'll see it actually opens it up in its own like window. So now if I want to change the material of this prefab, I can do that and it will save that prefab. Now if I go back to the scene, it's not going to remember that because I overrode it here. But let's say I put a new door here, like this, it's going to be blue. And now if I go back into the prefab, green, exactly. So if I change this one to red and I go out of it, that one actually updates because I didn't overrule it. So that's what I mean. Like if everything you set up in the prefab, it will remember, but you can override it. It gets a little bit more complicated if you actually start adding extra game objects to a prefab, because then it might start complaining and be like, do you want to unpack this prefab to make it unique? that's again too advanced. But yeah, that's basically how you would make all wooden doors metal doors in your level without having to go individually. You just change the material in the prefab. Any other questions? Okay, well, let's give the chat online a few moments as well. But yeah, I hope it was clean enough or understandable enough. If there are any questions afterwards, feel free to always message me. It was quite a lot for one lesson, but I feel like they're all tied so closely together that you kind of have to know all of these.
Maybe you can just quickly show it, because this is still example how to build the actual game, executive files, and then you can share them and run them on your computer without Unity.
Okay, so I'm gonna do that with the. Okay, the question was maybe I can show how to actually build the game so you can run it with the exe file, so you don't need Unity. So I'm gonna do that. I'm gonna use the more advanced game I made in advance. So basically it's very simple. You just go to File, you go to Build Settings, and you add the scenes you want to bring with your game. So you have your main menu and your first level. And then you choose which platform you want to make. Obviously I'm on Linux, so I will build for Linux. There's a few other things you can set up. We're not going to go into that, but here in player settings you can add like icons, what the icon should be from the exe file, splash screens, whatever. It's all in here, but you can Google how to do that if you want to. But it's basically as simple as choosing build and run or build, and then you say where you want to save it. So I'm going to call this like little first game. Okay, so it asked me to save because I didn't save, and then now it's going to compile everything. So here we go. It might take a moment. I'm going to take this opportunity to drink something. So there we go. It's compiling the shader I made. It's doing some material stuff. And obviously, since this is a very, very small game, it's going to go relatively fast. This is relatively fast for Unity. Usually takes quite a while, depending what you build for as well. And here we go. The game is launched. So now we have our little apps for the game. New game. Do you want to embark on the epic adventure? Yes, and I'm in my game. And here we go. I can open my chests. Obviously, there's nothing in my chest because I didn't program that yet. I have my door, and here we go. I'm out of the level. The first level is cleared. So, I forgot how to close an application. So, obviously, okay. I didn't do an exit menu. So, yeah. So, now, if you want to give your friends that program, you can just go to the actual, place where you built it. As you can see, I saved this in my folder 3D lesson. So I'm gonna go there real quick. So home 3D lesson. And now here you see first game data, first game x64. And basically you wanna, this is for Unity, this is the actual game. So if I would run this, and here you go, the game is there again, and now I'm stuck again because I don't have an exit menu. Or wait, I do. I have a quit button that actually works. So you basically would pass the folders like these and zip them and pass them on to whoever would use it. And not all of them. I built it in the wrong location. I built it in an actual project. Usually you'd build it in like a separate folder, but I was lazy. The question was, do you need all the folders? And no, you just need the ones that actually come with the build. I built it in the wrong folder, but basically it's the same for every platform. There's a few things to take note of though. If you build for Windows and Mac, usually you will have a folder which will say do not ship, which means don't give that folder to like the users, because that will have your pure code, while the other ones will have compiled code. And yeah. So yeah. Any other questions?
If you build for dedicated server, does that mean like Stadia and stuff?
I have no clue. I've never built for dedicated server. Maybe Andre knows. The question was, if you build for dedicated server, is that like for Google Stadia or something? I have no clue. I think that's just,
It's not.
yeah, I think it's just like if you actually have like a backend like type of Unity program for like a dedicated, like an actual world or something that needs to persist in backend. I don't know, but I'm not sure. I've never used that, so I cannot answer that question. Another one that might be interesting, WebGL builds for browser. So if you ever want to put like your game on a website, you can use WebGL for that. I think Andre used this in the beginning as well with Blender Worlds for tests. Obviously, the bigger the game it gets, the worse it runs on browser, because it also takes a while to load all the assets. But it can be convenient for a small game, like if you want to play it in a browser or something. You can do that too.
So one thing what you can do is build the game without your assets. Okay?
Mm-hmm.
And then assets you load from a server at point where you need them.
Okay.
Okay? So then your game is much smaller and can run in WebGL, and then WebGL will load
Okay.
and unload different assets. So assets don't have to be bundled with the actual code. They can be downloaded. So you can see many games you just install it and it's like loading assets, you know,
Yeah.
for a long time for the first time.
Yeah. So to repeat what Andre said, basically dedicated servers, if you don't want to pack your assets with the game, so the game size is a lot smaller, for example, if you use WebGL, and then the assets will be loaded when the game runs from that dedicated server. So, yeah. Any other question?
So if we want to build for WebGL, do we make the game in a different way? Or does it automatically know that it will load the assets?
No, it doesn't. WebGL will run the same thing in the browser.
Yeah.
Okay, exactly the same thing what you just seen. It will do exactly the same thing. However, the browser will say, well, I have not enough memory, and it will die. Okay, and if this game is 2 gigabyte, you launch it and then download 2 gigabyte before you start your game.
Yeah, I understand.
Okay, so it's not very convenient if it's very big. Okay, so that's why you need to split it in chunks and segments, but you also have to downsize your assets, you know, so they are not huge maps and huge textures and so on, so you have to downsize everything in order to make performance, speed, size, and all the other stuff.
Okay. So I don't know if I
We
should.
can talk about that later, so
Yeah.
it doesn't matter.
I'm not going to repeat that entire thing, but yeah.
I have no more questions, so we can...
All right, so I'm going to wrap up here. If there's any more questions about Unity, feel free to always message me on, well, whenever you want to message me on Skype or ask at work. So yeah, but thanks for watching. Hope it was educative. Yeah, see you guys next time.